Yeah, so let's get to the problem. So here we have pi rotation about yaw axis, roll of 90 degrees, pitch of 45 degrees, and that we input it here. Here you can see that we are substituting t1, t2, t3 for pi, pi by 2 and pi by 4. With that we get the matrix, our transformation matrix. So let me just pull the numerical values of it. Double matrix converts any expression into values, yeah, and this will be double by default. A double is a floating point with more precision, although it concatenates, but yeah. So yes, this is the rotation matrix that we get. So we invert this matrix because it's an inverse problem. The coordinate of tool is required. So this matrix, this transformation matrix with the transformation matrix actually performs from ground to tool. So the moment I have anything that is in the ground, if I multiply it with the tool, I'll be getting my transformation matrix. So I'll be getting my coordinates. Yeah. So I have to perform an inverse of the transformation matrix to attain to the answer. So the answer to this is 3 minus 2. This one you can see there is a similar type of answer in your um, assignment, but although I'm sure that you must get a different answer because there is different convention that is followed. So please be careful while working with these kind of conventions. Yeah. For week 1 you have your role and pitch. Okay, you have the same convention. So you need to work it out once to find the answer for this question. And coming to a question by Anand, I guess he was asking about this particular question. Is it right? Hello. Okay. Mm-hmm. Okay. Let me just check the messages. We have sent this question. For mobile coordinate 2, we have to consider homogeneous p4 comma 1 element as 1. Okay. I mean mobile frame position transpose of this equation. This question is regarding finding. Okay, I think that is the question that he is referring to. Yes, this one. It is the ninth question. Yeah. Then the fixed frame will be this one. This question is pertaining to. Yeah. Does this question come under the 10th, 11th, 12th, or because mine is little different from yours? Yeah. Yeah. No. This is, it's a true or false question, I guess. Right. Okay. So it is the ninth question. Mhm. Fixed. Yeah. For this question, yes, you will have to take. Yeah. you will have to take that element as 1 and then solve it. Right? Yeah. So there is also a question on transformation matrix. So let me just present my slides. There it will be clear. Okay. Given that here we saw that we are doing a sequence of rotation, that is the transformed axis or the transformed frame, we are taking that y-axis and rotating about that. What if that we had a ground frame of reference and we are asked to rotate above the ground frame of reference? Although this is not covered in the lecture, but it's good to know how to do a certain problem like this. So let us take that we are doing theta 1 rotation about x. Then you have x dash, y dash, z dash as your intermediate frame, and you are asked to rotate about y. And this is different from how we have done in the previous slide. Here this frame does not coincide with the y dash. So now you will have to make y dash as a function of y, that is you will have to transform it with respect to this old y axis, and based on that you will have to do rotation. You are not asked to solve any such kind of problem in the week's assignment. Let me reiterate that. So this is for your clarification what it means that to have a rotation with respect to ground frame or a frame that is away from your transformed frame. So here is some hint towards it. I would want all the viewers to read through it, and probably we can discuss the derivation of such a rotation that happens about some arbitrary axis, right? So Rodriguez rotation formula expresses any vector being rotated about any axis, arbitrary axis of degree theta, right? So this is the two components. Here you can see that the parallel will remain about the parallel b component about of with respect to k will remain where it is, and only the perpendicular will try to move when you rotate it. And that is also the case with what will happen with this kind of a problem. Although you are not asked to solve any such problem like this, this is only for the uh, sake of your knowledge to enhance. If someone asks such a question, what it means to rotate about a frame that is not in your transformed frame. So this is how you do it. And coming to the transformation matrix question, so I'll be not solving that question, but here I'm giving you a hint of how this can be done. This is to be done. They have asked you to do a DH algorithm, that is this is the algorithm in which we would express any rigid body about two axes x and z, this screw and twist axes, and based on that we can transform any frame to its end effector. And this is how DH parameter or DH algorithm would do, is that we will have a compound rotation or a composite rotation, first with z axis, then with the transformed x axis, that is this one. Okay, there's someone else joining. Yeah, yeah. So the rotation matrix will be a 3 by 3, but that will be a sequential rotation from z first and then x, and your translation matrix will be p1 plus p2, where you have a units translation in x-axis and d units in z-axis, and your perspective parameters will all be 0 since we are working with rigid bodies, and your scaling parameter will be 1. So this is the transformation matrix that you are required to construct for 10 to 12 questions, from 10 to 12. And from this, the p1 plus p2 what you would get would actually give you your x, y, and z axes, right? You can do it in a different manners. Yeah, you can do it in a different manner, that you perform translation first, sorry, rotation first. You multiply this rotation matrix with P1. Okay, this being a problem, people are joining in now. Okay. Yes, you are for 10 to 11 question, 10 to 12, you are requested to construct such a transformation matrix, and based on this transformation matrix, you will have to answer certain questions, right? So uh, this would be multiplied with each of the axes, that is 1 0 0, 0 1 0, and 0 0 1. Okay, in 4 by 1 notation, the last particular vector will be 1. Okay, let me just put it here. Yeah, so you would be having 1 0 0 1. This would be your x-axis, and right, based on that you would find px, py, and pz. So this would be your x, this would be your screen is frozen. Okay, give me some time. Yeah, stop sharing. So let me turn off my camera so that my bandwidth is not causing a problem. Better now. So to solve 10 to 11, we'll have these kind of axes. By multiplying these axes with t, you would get your px, py, pz, and this is asked from you depending on your question. So this is mostly the week 1 assignment. I would ask you if you have any doubts. So yeah, can we have the discussion? Yeah, you can speak up. Okay, people are joining in now. Okay. People who have joined now, you can directly express your doubts that you have in week 1. Probably I've, uh, I'm almost at the end of this lecture. So you can ask the questions. If uh, people who have doubts can also ask your questions now. Right, I'll be here. Don't worry about the time limit. We can extend the presentation or the session for 10-20 minutes. Yeah, one by one. Yeah, Abhirup. I did not get your pre and post. Can you elaborate? Yes, yes. Abhirup, to clarify further, I would say, see, look at it this way. The x-axis that they have given can be taken this way. One can also be taken the other way. Let's take, you have one transformation matrix, which is something like this, right? Right. So this t underscore 1, yeah, one transformation matrix which is like this. You can have the second, which is composite to the one, means after you have performed one, you do the second one. You can split this transformation that you are going through by intermediate frames, n number of intermediate frames you want. Let me just check if my recording is working. Yeah, it's okay. You can split it by n number of intermediate steps. You will still get the same answer, right? Maybe this one will be different. This particular equation will be different because they have mentioned that x-axis is with respect to ground frame, and hence this. So if the x-axis is with respect to the rotated frame, then you will have P2 here, right? The order would go, okay, there will not be P2. I'm really sorry because you have already done that. So the order will be T1, T2, T3. So T3 multiplied with T2. So let me just put it in equation. Yeah. Mm-hmm. You can split it again, something like this, right? Like you have mentioned, okay. You are telling me that you'd perform rotation about Z, right? First rotation about Z, then please speak up, then okay, then there is a translation. Let's do the simplest way. So now I don't have any rotation. So this is going to be a identity matrix. Yes. And this will be my rotation. Sorry, my translation. Sorry. Yeah. And then I have about y axis. Generally, for you'd see in your DH parameter, we generally don't use y axis. So it is always represented with respect to x and z, right? But your transformation matrix can have y, don't worry, right? So this would be the sequence. Yes. So the sequence has to be preserved. So again, you would get your resultant transformation matrix as a multiplication of three matrices. First you have done T1, then T2, then T3, then you get the composite transformation matrix. Yes, whatever you have performed first, so it's going to be something like this. Now T1 you have got. Let's assume that you have got T1. So any transformation that you do on T1 will be multiplied with T1, right? So how does matrix multiplication work? If I have A, I do any operation on A, so the B will fall to the left of A, right? That is the order in which it will. So I am doing an operation on T1, that is resulting T2. I am doing an operation on T2, that is resulting T3. So it is from, let's, if I take 1, 2, 3 as the frame, T1 takes me from 0 to 1, T2 takes me from 1 to 2, T3 takes me from 2 to 3. In standard literature or even in standard textbook, John Craig, introduction to robotics that is prescribed as a lecture material or a book for reference, they represent this particular matrix something like 1 to 0 or 0 to 1, bottom 0, top 1. So t to the power, or okay, let me just make it here. It generally is preserved on the left side, but okay, right? So this is a kind of notation that is used so that you understand it's a transformation from 0 to 1. From 0 frame, you apply this matrix, it will take you to the first frame. Okay, so this is how it is done. Here it will be 1 to 1 to 2, right? So here it will be from 2 to 3. So at last, the multiplication of all this will give you from 0 to 3, right? 0 to 3, yeah, something like this. So from 0th frame to the 3rd frame, this is the composite transformation matrix that will lead you there. Yes. So now you multiply any vector to this, you will get your vector transformed into the third vector, third frame. Sorry. Yes. Is there any more question, Abhirup? I guess this answers questions. Joining in late, if I guess few of them must be joining for the 5 to 6 lecture. This is the 4 to 5 lecture. There are 2 lectures scheduled. One is from 4 to 5, the other one is from 5 to 6. One of my colleagues will be taking it. He is from a different institute. He will be taking it, right? Yeah. So, is there any more questions? We can extend this meeting for 10 more minutes. Don't worry. Yeah. Okay. Sir, I missed lecture. Please address me as Vivek. Sir is not for me. So, yeah, I missed the lecture week 1 lecture because I applied just yesterday. Okay. So is there a way to watch first week lecture? Yes, Pranav, you can watch this in the link that NPTEL has provided. Python source code link, please, as you have told. I have not made the Python code yet, so I'll be sharing you the code and the folder link, so you can find both MATLAB and Python source code for such a for this simple problem. Yeah, I've not made that yet. I'll make it and send it to you. Mostly by today or tomorrow, you must be getting the link. I'm not sure. Actually, these links are shared by NPTEL themselves. I'll not be taking care or of um, sending these links to you. Okay. My question is for calculating. Guys who are joining for 5 to 6 lecture, this is 4 to 5 lecture. We are almost at the end of it, but nevertheless, you can ask your questions. I'm here for the next 10-15 minutes and I can answer them. Yeah, my question is for calculating fixed frame. We have T is 4 by 4 matrix, PM is 3 cross 1 vector, right? For multiplication, we make PM 4th row first into 1 so that PM makes 4 by 1. Yes, Anand, you have to maintain that consistency. So if you have your position vector with respect to the mobile frame as 100, then you need to make it 1001 so that you can multiply with your transformation matrix. Yes. Webhubs, so I'm from Temple branch, so I don't have knowledge about various software, so I can continue. Yes, let me reiterate for the people who have come in. This software is not mandatory. We are just taking an extra effort to learn it. The course does not demand you to know any of the software, either Python or MATLAB. The course does not demand you. You can do it manually, purely. But taking robotics, the essence of it always lies in programming, right? So it's a good thing to learn. That's what I would assist Weber. Can you share these? Yes, Dibyanshu, this will be shared. This will be shared by the NPTEL team. I will not be sharing it, but yes, the link will be provided by NPTEL. In the algorithm for composite rotation, what is the logic behind the post and pre-multiplication? I guess this is answered by this question is asked by Abhirup, and I guess I've answered it. Is that ground frame is fixed frame? Let us not get confused in the kind of frames that you use. Ground frame, generally we fix it, and there are literature which takes ground frame as variable. So yes, ground frame is sometimes fixed. Please solve my problem. Okay, please zoom in source code. Dibyanshu, I'll be sharing the code, please don't worry. Enlarge the font. I have Octave, you can use any software. It's just to understand how things work. I don't have MATLAB license, it's alright. Yeah, Melody is this, I need MATLAB. I will not be providing MATLAB license because we all are from different institutions, organizations. So I will not be providing any software, but yes, I can give you equivalent open source codes, and that will be working just fine. Yeah, I guess this is end of it. Anyone else has any questions, you're free to ask. Yes, I'll stop sharing my presentation. Right. I guess nobody else. I think I've joined. Yeah. So get crack version, Abhirup. Don't encourage anyone for crack. Yeah. I don't know anyone Python. Yeah. All right. So I guess we are end of this course. Let me stop recording.